Every day, millions of people cross concrete bridges without a second thought. But corrosion damage to America's highway bridges alone costs $8 every single year. Most structural failures don't begin with a collapse. They begin with a crack this small. When rain falls, water quietly enters, and that single crack becomes the starting point. Beneath the surface, steel reinforcement begins to rust. And rust doesn't just weaken steel, it expands, pushing outward and cracking the concrete around it from the inside. As months turn into years, that crack slowly grows. More water enters, more corrosion begins, and the damage spreads deeper inside. That's why U.S. highway bridges alone see over $8 billion a year in corrosion repairs, plus the traffic delays, lane closures, and disruption that come with every job. Instead of repairing the same cracks again and again, one question started changing the industry. What if concrete could repair itself? That question led to one of the most exciting materials in modern civil engineering: self-healing concrete. At first glance, self-healing concrete looks identical to ordinary concrete. The real difference is invisible, hidden inside as thousands of microscopic healing capsules. Just like ordinary concrete, small cracks can still form. The difference is what happens next. When water reaches the crack, it travels inward until it touches one of the hidden healing capsules. The capsule ruptures and releases a healing agent. It flows into the crack, hardening within days and sealing gap wide, about 3 times wider than the crack's codes normally allow. Over the next few days, the healing agent hardens into a protective seal that blocks water from entering again. There's a second method too. Some self-healing concrete uses dormant bacteria that wake up in water carbonate, essentially growing their own limestone patch to seal the crack. In lab testing, self-healing concrete has sealed cracks up to nearly 1 millimeter wide and cut water penetration dramatically compared to ordinary concrete. The difference is clear. One crack keeps growing and lets more water in. The other seals itself before it ever becomes a bigger problem. Today, engineers are testing self-healing concrete in bridges, tunnels, and parking structures. Like any new technology, it has real challenges. Self-healing concrete can cost 30 to 50% more than ordinary concrete, and its long-term performance over decades is still being studied. As research continues, this material could help future infrastructure last longer. The strongest structures of tomorrow may not be the ones that never crack. They may be the ones that know how to heal. Stories behind the world's greatest structures.